Introduction. Design rigorous experimental procedures with GenAI assistance to effectively test hypotheses and control for variables. Welcome to this session where you will learn how to create well-structured experiments using generative AI. This ensures your tests are accurate, reliable, and scientifically valid. Why rigorous experimental design matters. A strong experimental procedure controls variables and reduces bias. It allows you to test hypotheses with confidence. Poor design can lead to invalid conclusions and wasted resources. How GenAI supports experimental design. GenAI can help plan experiments by suggesting protocols, identifying key variables, and recommending control methods. It accelerates the design process while maintaining rigor and clarity. Defining experimental goals clearly. Start by specifying your hypothesis and what you want to measure. Clear objectives help guide the design choices and ensure relevant data collection. Identifying variables to control. Use GenAI to list independent, dependent, and confounding variables. For example, prompt, list variables to control in an experiment testing sleep quality and diet. This helps prevent unintended influences on results. Choosing appropriate controls and groups. GenAI can suggest control groups, randomization techniques, and blinding methods. For example, recommend controls for a drug efficacy trial. Proper controls increase experiment validity. Planning data collection methods. Determine how, when, and what data to collect. Use GenAI to create data collection schedules, measurement tools, and sampling methods. This ensures consistency and reduces errors. Ensuring replicability and transparency. Document your experimental steps clearly. GenAI can help draft detailed protocols and checklists. Well-documented procedures allow others to reproduce and verify your results. Real-world example. Clinical trials. In drug testing, GenAI assists by designing double-blind, placebo-controlled trials. It helps identify variables like dosage and patient demographics to control for, ensuring reliable results. Real-world example. Behavioral studies. For a study on learning techniques, GenAI suggests random assignment of participants and controls for prior knowledge. This reduces bias and clarifies cause-effect relationships. Iterative refinement of experimental design. After initial design, test and refine your procedures. Use GenAI to identify potential weaknesses or confounding factors. Adjust protocols accordingly for better results. Reflecting on your current research. Think about your last experimental study. Were your variables well controlled? Could GenAI have improved your design or documentation? Best practices for designing experiments with GenAI. Involve domain experts alongside AI suggestions. Validate AI-generated plans with your team. Use modular designs that can adapt to new findings. Keep clear records for auditing and review. Tips for crafting effective GenAI prompts. Be specific about the hypothesis, variables, and type of experiment. For example, say, design a randomized controlled trial to test the impact of exercise on memory retention. Clear prompts yield focused and practical designs. Conclusion. Designing rigorous experiments is critical to testing hypotheses effectively. With GenAI's assistance, you can create thorough procedures that control variables and reduce bias. This leads to trustworthy and replicable findings. Thank you for joining this session. Start using GenAI to enhance your experimental design and produce stronger scientific results.